Hello, I'm Scott Specker,
And I'm Eric Wilbur.
and we're here to present the Energia Arduino chapter. This is aimed at the Msp430, but actually this presentation would work if you were working with Stellaris as well, because both boards are supported by Energia.
I'm glad I brought my energy drink along. Help me through this presentation.
Okay, you're taking over all the puns now.
Yes, I'm the bad pun color commentator for this whole deal.
Okay, sorry folks.
You got to live with me or live without me.
I got to live with them too. So what is Arduino and Energia? That's our first kind of subject we want to cover. So we're going to talk, let's just jump right into Arduino, and then once we understand that, we can hopefully use that to figure out what Energia is. Okay, so what is Arduino? Arduino is an ecosystem. That's the way I think about it. It's hardware, it's tools, and it's code. And I've heard people say that Arduino is just one of those items and argue about that. But in general, I think it's really all of those. It started with a single Arduino board, but there's a whole lot of variations that have grown out of that. It's a set of tools that allow you to create the code. They call them sketches. The little programs are called sketches, and download them to the hardware. And then what is the code you're creating? It's something called the wiring language, which is really just C, C++ with a wiring library of functions. The concept here, though, why Arduino? So we've got hardware, tools, and code. We've got this ecosystem, but what does it really mean? I like the phrase that they use oftentimes for Arduino called physical computing. It's the idea of, I want to be able to take software and get things to run in the real world. When you learn programming in college, it's oftentimes, or wherever else you might learn it, you're doing maybe Windows programming or Linux programming. You're just staying within the world of the PC. Nothing ever happens outside the PC. Arduino's kind of trying to look at things from a different angle. It's like, how do I get stuff to happen in the real world? Physical computing. So it's become very popular for hobbyists and open source programmers because it's all based on open source coding. And it's, for those people who actually do programming for a job, who do embedded systems for a job, it's actually becoming pretty popular as a rapid prototyping vehicle as well, and some even go to production with it. Some don't, some do.
So you can use Energia or Arduino to create a real system that's doing, a real piece of end equipment.
Oh, you absolutely can.
And there's nothing that keeps me from doing that.
Nope, there's nothing that's going to keep you from doing that.
Just because it's simple doesn't mean you can't do a lot with it.
That's a very good way to put it. Yes, exactly. Thanks, Eric.
Yep.
That's kind of a quick snapshot of Arduino. What is Energia then? So what do we mean is Energia is actually the TI support for Arduino. So you can really only call yourself Arduino if you're actually using the Arduino boards as part of that ecosystem. So there's a group of, there's some people that went off and created a fork or a port of the Arduino code that would actually run on the TI platforms. You can see right there in the middle of the page what supported the Msp430 Launchpad. There's something they call the Launchpad, which is an FRAM based development board, and also the Stellaris Cortex M4F Launchpad. So
now the only MCU I see missing is the 28X.
And today the 28X isn't supported, but there's I think this group is working on doing the 28X Launchpad.
Okay, yeah.
And there's also, they're looking to support other boards, other Launchpads that are actually coming out later this year. So the goal is to kind of support the Launchpads, and who knows where it will go from there.
Right.
But most of these people are doing this in their spare time because it's an open source project.
Supported,
yeah, so TI doesn't own this project. It's not a TI thing, but it happens to be for TI boards. So they took the software, the wiring language, and the tools, and they ported them to this hardware. Because they did that, they had to come up with another name. So somebody came up with this idea of Energia, which, if you know your Soviet history,
which I don't.
We all do, right? Oh, you don't? Oh, okay. Energia was actually a rocket. It was one of the really heavy-duty rockets that, in fact, was intended at one point to, if they had a shuttle program, through the concept or production, it was going to be the one to lift their shuttle up. But that's where the name Energia comes from, and
So we named it after something that never launched.
Yeah, thanks a lot for that. No, they actually used the rocket.
Oh, they did. Okay.
Yeah, they used it as
That's
a heavy lift
part.
as a heavy lift rocket. They just didn't have the shuttle
Right.
part. And I think it all came from the TI Launchpad.
Oh, yeah,
So
I get it.
this is what's
rocket
getting you
name.
the rocket coming off the launch pad or
All
something
right.
like that. Okay, so you can see we got a question that comes up there and says, what does an Arduino Energia program look like? Before we go look at that, we'll look at that in a second. Let's just talk a little bit about the lineage, just
Where Arduino
where
came
Arduino
from?
comes from.
Okay.
I found that really kind of instructive myself, so I kind of like to know that. So you can see that way back in the 1990s at MIT, there was a project called Design by Numbers. It actually was a language as well. And so this was a kind of, how do we get non-programmers, artists and people of that sort, programming? And so it was really aimed at ease of use.
So it's a very high-level language.
It was a high-level language, very
simple.
akin to what we're using with Arduino today. That in 2001 was adopted by some other MIT people. They kind of took that concept and turned it into the processing language. That was what the language was actually called, was processing. It really built on Java, but with kind of a simplified syntax. And they talked about the programs here being sketches. In fact, today that name still sticks around. The programs are called sketches. So once again, it was really aimed at non-programmers. In 2003, some folks actually down in Columbia came up with, they kind of adapted processing to what they called the wiring language. And this was really more on C++ programming aimed using this wiring language. They're using a Java IDE still, and it was really aimed now at microcontrollers. And then finally in 2005, somebody took some folks in Italy actually took the wiring language and adapted it into something called Arduino. And that's where the very first Arduino boards were created. In fact, the name comes from Italian. Yeah. So it was, again, teaching, happiest, rapid prototyping. Those were the kind of things that were aims and goals of Arduino. Also out of the wiring language is a language called, or a project called Fritzing. The idea was to go along with Arduino if you wanted to build your own board. So electronic design tools was kind of what that was aimed about. We're not going to be covering anything along that line, but it was just part of the lineage. And then you can see that in this past year, it was ported by a group of folks from Arduino to Energia. I say a group of folks, so really one guy in California working for TI in the evenings and such really did most of the work.
Let's hope he's being well paid.
I hope so too. So it's really a direct fork of our Arduino, and it's really aimed around the TI microcontrollers as we've talked about. So that's really where Energia came from.
All right.
So back to our original question was, what does a wiring sketch look like, or what does a program for Energia look like?
And if you're familiar with Arduino, this should look very familiar, right?
In fact, the language is going to look exactly like, if you're coming over from the Arduino world, you'll feel right at home. And you can see here's what the programming looks like. So on the right-hand side, we just have a very simple program. As we say on the bottom major bullet there, this is the blink function, and it's the embedded systems concept of hello world.
Right.
Can I get an LED to blink? Can I get something out on the outside of the processor to blink or do something?
And sometimes that could take a week.
Yes. Here it's very, very simple. So Arduino programs, or sketches as they're called, you can see that they really consist of two functions, setup and loop. Now you can have additional functions as well, but you have to have at least those two functions.
And to me, this makes a lot of sense, because in typical programming or common traditional programming, you have initialization of a peripheral or something, your clocks, in the top of main, and then somewhere toward the bottom of main you have a while loop waiting for real-time activities to occur. So this makes some sense.
And since this actually is in the real world a C program, what the tools actually do for us, as when you hit the compile button or the download button, it's actually going to take your functions and it plugs them into a main function. It's actually going to call setup, and then it's going to call loop over and over again, an endless loop. So it really creates a main function. It's just we're going to think about things in a very simple setup and loop type strategy.
Right.
And if you think, loop, well, could we do things with interrupts and be... Yes, this is the real world. We want to talk to the physical world. So in an upcoming lab exercise, we actually explore using interrupts as well. But a lot of times the things we can do can actually simply get done in a loop, as we show here. So that's the overall concept. We've talked about it being C, C++. We've talked about having these two functions. And we've talked about it, you kind of asked the question, would Arduino people recognize this, portability? If you see the fourth bullet over there on the left-hand side, we can actually use all the hardware features of the underlying platform. We see people doing that in the Arduino world. We can also do that in the Energia world.
So I can write hardware-specific C code like I'm used to outside of Energia or alongside the Energia call.
So in the setup function, I could actually call, if I wanted to change, it's got a default clocking. It actually, in this case, I think we set it up to be 16 megahertz, running at the full speed of the Msp430 value line Launchpad. But if you want to change the clock speed, you could actually just in setup add some additional code to change which clock speed or which clock you're using.
So it doesn't preclude me from doing that.
No.
But if I wanted to port that code to Stellaris, obviously that's not going to be portable at that point.
Correct. So if you add that extra code, it will hurt your portability.
Right.
But on the other hand, it gives you the full flexibility.
Okay.
And if you wanted to change the default clocking so you didn't have to change it in here, you could actually go modify. Everything is provided in source code.
And just rebuild the library.
Yes.
Okay.
Yep. So it's not a difficult thing to either change the defaults or add the specific code here.
Okay.
We will add hardware-specific code in the last lab of the workshop.
All right.
So we'll get a chance of this chapter, we'll get a chance to play with that. So that's what the Energia Arduino programming looks like. And what are the different functions of the Energia? I won't take you through them one by one. I won't subject you to
And
that.
again, if an Arduino user is looking at this, they're like, yep, I feel happy. I know this stuff.
That's right. So here's a reference of the functions and variables and things of that sort. So you can see the ones here, the digital write and digital read, those are two of the ones that we looked at just on the previous slide.
Right.
So these are functions that are built into the wiring language that make it easy for us to do these activities. And when we talk about porting or being a fork of Arduino, it's really somebody had to come in and write the Msp430 version of those functions. Somebody had to sit down and figure out.
Stellaris versions.
And Stellaris as well, and whatever other board it gets ported to.
Right.
We just have to go in and rewrite those underlying functions. So how does the Energia code, you kind of refer back to our look compared to our original C code. So if you'd actually taken other chapters in the workshop, you would have seen the code over here on the left-hand side. There's our main code, our main function with the setup at the top, and you can see down at the bottom is the background loop, the while loop. And so you can see there's a lot less code over on the Energia side. So a lot of that, again, a lot of the things kind of disabling watchdog timer and setting up the clocking, that's just all handled for you automatically. And again, if you want to go change those features, you can.
If I wanted to write the code on the left-hand side along with Arduino or Energia calls, no problem, right?
I mean, if I wanted to take setting up the clock and insert it over there?
Yeah.
In fact, we do that in the last lab exercise as a way to change the clock to go from 16 megahertz to 1 megahertz.
Okay, Scott, if I look at the code on the right-hand side, obviously much simpler. I just call pin mode as a function. Does it do basically what the code is doing on the left-hand side?
It does. The part where we're setting up the pin. Yeah.
So it's basically one for one, but it's a lot simpler to write in Arduino or Energia language than it is on the left.
It's
standard C code.
We oftentimes call this as a more abstracted language, or it's an abstraction. So we take the more hardware-specific underpinnings, and we just have a simple function that does the job for us.
But is there a downside? I mean, if I use the code on the right-hand side, am I giving up? Does it create more code space? Is there a downside to using the Energia language versus bit banging on the left?
I don't see the downside. It's roughly would be the same. I mean, the compiler is going to be the same type of, it should give you roughly the same type of performance between the two. You could say a negative would be that, the pin mode function is already written, so I work at an abstracted level and I don't get to work with the details.
But again, like you said earlier, I could go into that C code for pin mode and rebuild the library if I really wanted to.
I could go change that function.
Yeah.
That's one thing. The other one is I could actually take and add my own hardware-specific code to it, so I'm not really out anything there.
But again, all that defeats the purpose of
the
using
portability, if
the-
you care about the
Right,
portability.
right.
Now, the last thing is it really depends upon how good the programmer was. And I have not looked at all the functions, but I've looked at a couple of them. The one I think that's really interesting to look at is this delay down here in the background loop. So you can see delay cycles, that's a,
On the left-hand side.
on the left-hand
Yeah.
side, that's an intrinsic function. And in fact, when you run the TI compiler, it actually comes up and says, that's not the most efficient way to do that. That's the processor running, doing nothing.
And you're burning power.
And you're burning power. So it says, hey, we could use a timer to make that more efficient. And actually, that's cool. The TI compiler does give you that feedback.
That's very nice of the
It is
compiler.
nice. Yeah. Now, so I was thinking the same thing would exist in the Energia one, but as I went and looked at how it was implemented, they actually implemented delay with a timer. So they set up the timer, a couple of cycles, they go to sleep. When the timer ends, we come back out and move on down to the next instruction. Very slick. Very nicely
So
done.
the person who ported this did a great job with
He's
the
done
delay
a,
function.
He's done a very good job with the
especially.
delay function.
Well, that's what you would
Everything
want on
I've
an MSP430 is if you're not doing anything, you want to be asleep.
You want to sleep.
Yeah.
Yes. And everybody nowadays seems to want to save power. On the MSP430, it's one of those
Especially.
things everybody really especially likes.
Right.
So how do, we talk about LED pin here. What does that mean? And so we have to look at how Energia was ported.
Well, on the previous, a couple slides ago, we had LED pin 14. I remember that being a pound to find.
Was an
In
LED.
the blink LED.
Yeah, pound defines, C code, right?
Right.
Yep, so we can use pound defines in our Energia code as well. And this is where that came from. So you can see that, well, let me talk through this slide just a little bit, because I've had some people ask some questions about this.
All right.
I think they did a really nice job when they ported Energia there's a map like this for each processor. Okay, so the older Launchpads had a different processor. He's got a different graphic for that one versus this one. So here's the MSP430 with the G255 or 2553 version of the processor. And in here, I guess let's start in the very innermost columns. These columns 1 with pins 1 through 10 and
The ones
11
in
through
black.
20.
The
Those
ones-
are the ones in black on the innermost column. Those are the Arduino pin numbers. So when we talked about pin 14 being an LED, well, let's go look at that.
On
If we
the
go to
right-hand
pin
side.
14, you can see it's connected to the green LED.
Green LED, yeah.
So the outermost column of the little tables there next to the board represents the hardware. So you can see the green LED is connected to that pin.
Pin 14.
Pin 14. And I kind of like it because you can kind of see the pins, the board, the Launchpad has these, header connectors, and they do a nice job of silk screening on the board itself. What, for example, if we go to pin 2 on that header connector.
In the black.
In
Okay.
black,
Yeah.
and you go to the silk screen of the board, that's P1.0. So for the MSP430, that's port 1, so GPIO port 1 bit 0, or
Okay.
pin 0. And that's pin 2 for Arduino speak. We can see that's connected to the red LED from a hardware perspective. And then the three columns that we haven't looked at in between, if we look at that Arduino pin 2, you can see there's the green, which is the next column over, blue, which is A0, that's the next column over. So those are color coded, and you can see the legend up there over in the right hand, kind of middle right hand side.
Right.
So the green says that I can use a digital read or a digital write function. Oh, and in fact, that's what we were doing.
And if I do that, I would use P1_0 with those functions.
Oh, I can actually do pin 2 as well.
Oh, okay.
Arduino pin 2.
They're the same.
So just like we did pin 14, that one, that's purple there. So it says that pin could actually be used for digital read, digital write, or analog as well, analog write. The blue ones, the A0, A1, A2, up through A6 and A7, that's the analog read, which is basically the A to D converter. This processor has a built-in A to D converter, and those are the pins that are actually mapped to the inputs of the A to D converter. And then the kind of that
Orange.
the other column, the orange RXD, for example, and TXD, you can see that that's the serial UART. You can see that I can actually use pin 3, for example, could be a digital I/O pin, an analog input pin, or a serial port pin. And most modern microcontrollers,
One pin has multiple uses.
one pin has multiple uses, and that just shows you how you could do. You would only want to use that pin 3 in one of those ways at a time.
Right, of course.
But I could use any of those types of functions with those. So that's kind of how this is built. Most of what we're going to be looking at is red LED, green LED, which are circled on this one. Push 2, which I didn't circle, but that's connected to pin 5. Those are the 3 that we're going to use the most often. Okay, with that, let's move on and look at the tools. So the Energia IDE. The Energia IDE is a very simple debugger. It's a debugger. It will compile, it will build, and it will download, to my board. It's very simple. If I click the download button, which you can see over here on the right-hand side, blown up, you can also see it in the IDE. That will actually build and download to my board if my board is connected to the
Unless you have errors,
PC.
of course.
Unless you have errors, of course, yeah. And if you want to just test without downloading, you can do the verify compile, and that just does the compile piece of it. So it's very simple. And there's no long involved install process. You get Energia, you unzip it, and you're done.
And you run it.
and you run it, yeah. You unzip it and you run it. Sounds like one of those infomercials.
How does this relate to Code Composer? I mean, are there plans to, if I'm used to Code Composer, supporting Energia on CCS?
Well, a couple of different things here. Let me talk about that. So it's a more simple IDE than
the Energia
Debugger. Code Composer Studio supports many more targets, a lot
full
more
feature.
functionality. It's based on the Eclipse platform.
Right.
It's a full, massive production level tooling.
Right.
And you can do a lot with it. Some things you can't do here. So, for example, the Energia Debugger doesn't let you do breakpoint debugging. So that's one of the few negatives I see. Right. On the other side, this is simpler. You can install the Energia Debugger by just unzipping it. It comes with all the wiring libraries. It comes with everything you need to get up and running.
It's all self-contained.
It's all self-contained, ready to go. And it's a much smaller footprint. So that's kind of the comparison between the two. The Code Composer Studio team, by the time you listen to this, it may not be available yet. Or if you're listening to it a year after we talking about this, it may be available. But they're working on some ways to be able to import Energia projects into CCS. So you can actually take your sketches and import them right into CCS and build them in CCS.
Okay.
And it gives you some additional features. So the last thing I'm going to talk about is that debugging thing again. Since this doesn't have the ability to set breakpoints and trace in that particular methodology.
And that's common with open source debuggers anyway.
Yeah. So I've worked in Linux for quite a while now, for the last few years. So between Linux and between working with Arduino, we get used to just using, what's the most common
printf.
way to do printf. so we effectively are doing a printf. We'll actually do it over the serial port. So I'll have a little terminal. There's one either built into Energia you can use, or you can use your own favorite terminal program. And that can be used to effectively send printfs. So that's one way. The other one is just toggling pins. I say here, watching with an oscilloscope or a logic analyzer, or I don't have either of those handy most of the time when I'm debugging. I'm usually on the road, so I don't carry those with me. Just using the LEDs that are connected to pins is a good way to say, I got to that part of that routine.
Right.
So that's how most of us in the open source world do our debugging. So examples. What are the examples that come with Energia? Lots of examples come with Energia. So if you look down there, File, Examples, and then there's just this whole long menu of
categories. Really, it looks
categories
like
of examples.
You're just on the basic one.
I'm just looking at basics.
5 of them. Okay.
So Blink, that's actually the one we've been working with in the discussion here. And that'll actually be the first one that we do when we go to the first lab. Bare minimum is 2 empty loops. Can you guess what they're actually named?
Setup and loop.
You got it. Woo-hoo! Yeah, you got
That
it.
was a test.
That was a test.
I'm glad I passed.
So that's the bare minimum. It's just 2 empty functions. Blink is the one we'll start with. And in fact, most of our lab exercises will start with one of these examples and then modify it to do something slightly different or unique or add features to it. So these are all the different sketch examples that come with it. Energia Arduino references. Where do we go for more information? So we've got a kind of a big long list of things here. You can see up at the top is all of the kind of Energia resources, whether the wiki, the forum, the home page where you download stuff from. And then down at the bottom I've included 3 references for Arduino itself, because hey, when you're learning to use Energia, oftentimes you're going to be able to go use Arduino sketches as a way to get started doing something you want to do.
So if I have a problem, if I'm using the Energia Debugger and there's a code problem, or maybe I found a bug or whatever, how do I get support?
I don't know, because I never have problems.
Oh yeah, right. Tell the truth, Scott.
I'll
We're
tell
on
the truth.
video.
The answer is that support forum that we show really like right in the middle of the page. We had mentioned it earlier before on the 430o.com. There's a forum, and it's really active. I find
Lots of questions and answers on
and
there.
it's not just TRs on there. It is
the whole community.
It's the communities on there, and the folks who are supporting Energia, who are part of building it, are very active on there as well.
So when you were developing these labs, did you run into some questions and actually use the forum?
Should I be ashamed to say or not? No, I'm not ashamed to say. I did run into some problems here or there where I was trying to do some, usually when I was trying to do some unique things, especially when I was trying to add in some hardware specific features.
Okay.
And I ran into some problems. I couldn't get something to work. One in particular was the push button. I was trying to use the push button as an interrupt, and I couldn't get it to work. And what I found is I had to actually change the way the input, I had to be set up with a pull-up resistor.
Okay.
Or is that a pull-down resistor? We'll see that in the upcoming
It's
lab.
in an email somewhere.
It's
on the forum.
It's on the forum, and
Yeah.
it's also in the lab exercise here. But yeah, I was just missing that, and somebody mentioned that. I went and tried it, and boom, I was up and running very quickly.
So you got assistance from the forum then?
I got assistance from the forum. Yeah.
Okay, good.
Yeah, so really good resource to go to. Lab exercise. So what are we going to do in this lab exercise? Coming up. If you haven't installed Energia, so if you're taking the workshop, you've probably already installed Energia as part of the installing all the pieces for the workshop.
Otherwise, this is step number 0.
Yeah, otherwise step 0 is just downloading the file and unzipping it. Yeah, and we have you change one folder so all of our sketches go into a known location. Then really the next 5 sections of this lab are blinking the LED, so just getting the LED to blink, and then we have you look at a few things and adjust a couple things there. The push button, this is not the push button interrupt like I mentioned just a minute ago. This is actually just pushing the button, and then we're reading it in that loop. So it's a
Kind
less
of an inefficient way because
it's
you're
a little,
polling.
yeah, it's a little less efficient solution for the button, but it's a good starting point.
Right.
Okay.
Walk before we run.
Walk before we run. Then we're going to get into serial communications and debugging. And the whole idea there is, can I send, well, a lot of people want to be able to talk over a UART. So this right here shows you how to talk over a UART. We happen to be talking over the USB cable that's going back to the PC. So we're using this, what they call a back channel UART. But that's how we're going to do it, so we can actually see the messages show up on our computer.
On the terminal.
On the terminal,
Right.
Yes, in the computer, exactly. So that we're doing that. So a lot of people will just want to use the UART. There's some people, though, who will want to use this for debugging as well. So that's why we say and debugging. Interrupts. How do we set up interrupts? So there are a couple things that are managed for us. Most of the interrupts, like if I want to do a push button or I want to create my own timer, those are the things that we actually look at here. So we do a GPIO interrupt and we do a timer.
I'm excited. I'm excited to go try these labs.
So let's go ahead.